In the previous few videos, I showed you how to apply the output cache attribute to your controller actions to cache the results and reduce the number of times they get executed. Output caching is a great way to avoid executing long-running operations more than you have to. But what happens when you have a controller action that includes a long-running operation that you can't apply output caching to? In this video, I'm going to show you how to run those controller actions asynchronously. Then, at the very least, you can keep them from affecting the other requests that your site is handling at the same time. In order to appreciate the full power of executing controller actions asynchronously, or why you would even want to do so in the first place, we must first talk a little bit about how ASP.NET handles web requests. When your application starts up, a certain number of threads are created and assigned to it, collectively known as your application's thread pool. When a request arrives, ASP.NET grabs one of the threads from the thread pool to handle the request. If the process is synchronous, as most are, the thread will be blocked from handling other incoming requests until the current process is complete. In most scenarios, the request being executed is short-lived enough that this doesn't create any issues. However, if the application needs to handle a large number of incoming requests or a large number of long-running requests at the same time, the thread pool might become depleted, and a condition known as thread starvation will occur. When this happens, the web server will start queuing new incoming requests, causing them to become delayed. At some point, even the queue may fill up, and at that point, any new request will simply be rejected, and the user will see nothing but an error page. To prevent the thread pool from becoming fully utilized, you can tell ASP.NET MVC to execute the actions in a controller asynchronously. Using an asynchronous controller does not change the amount of time that a request will take, but it does free up the thread that's executing the request so that it can be allocated back into the ASP.NET thread pool, making it available to handle other requests. Then, when your long-running task completes, the controller regains control of the thread and renders the completed result. It's important to note that asynchronous controllers don't come free because switching threads is an expensive operation. So be sure to reserve this approach only for appropriate operations because completing a short-running operation asynchronously can actually take longer than the standard synchronous approach. While there are no hard and fast rules regarding when to use asynchronous action, consider the following guidelines. On the left, you have the typical scenarios where it's best to use synchronous actions. These are simple and short-running operations, or perhaps some long-running operations where simplicity is actually more important than efficiency. And finally, there's the CPU-intensive operations. While CPU-intensive operations are a common cause of performance problems in a web application, running them on a separate thread will not help. Remember, the server only has so many CPU cycles at its disposal. On the right-hand side, I've listed some typical scenarios where it's preferable to use asynchronous actions. The first is long-running operations. In other words, operations that take greater than about a second to run. Next are network or I/O-intensive operations. These are much different than the CPU-intensive operations I mentioned earlier. This is because usually the CPU is sitting idle waiting for something else to happen, such as network activity or disk activity. Another great scenario for asynchronous controllers is when users may want to cancel a long-running operation before it's completed. Running this operation in a separate thread allows users to come back and cancel it later. Now that I've explained the concepts behind asynchronous controllers, it's time to see them in action. Despite how complicated my description of ASP.NET threading sounded, creating an asynchronous controller is actually fairly easy. All you need to do is create a controller that inherits from the async controller base class. Here I've created an async controller named search controller. Now I can begin implementing controller actions that utilize the async and await keywords and return a task of type action result, like the one shown here. In this example, I am using the .NET Framework's task.run helper on line 14 to execute a few lines of code in a separate thread. I'm also using the await keyword, which will wait for that task to complete, and then continue executing the method when it does. Since this all happens asynchronously, the whole method needs to be marked with the async keyword on line 12 and return a task of type action result as its return value. The fact that the action returns this value indicates to ASP.NET MVC that the controller action should be executed asynchronously. Now, when we run our site and navigate to this action, we can see our JSON result returned. Notice that from the user's standpoint, nothing actually changes. We make a request and we get a response eventually. All of the differences lie in the way that the server processes the request. In this video, I showed you how to run long-running controller actions asynchronously to keep them from blocking other requests coming into your site. In the next video, we'll switch gears one more time, changing the focus more toward the browser and seeing how the techniques of bundling and minifying your site's content can provide great benefits in the perceived performance of your site.